This is worksheet 23.2, solving rational equations. And we're going to first look at the problem for questions 1 through 4. So considering this equation, what algebraic strategies would you use to solve this problem? We're going to look at two different strategies we can use. One method we can use when we have one fraction on the left and one fraction on the right side of the equation is cross-multiplying. Another strategy we can use to solve any rational equation is to create common denominators. And we'll look at both ways of solving this problem. So in number 2, we're going to solve the equation by cross-multiplying. So I'm going to write the equal sign down. On one side of the equation, I'm going to multiply 7 and x minus 1. And on the other side of the equation, I'm going to multiply 1 times x squared plus 3x minus 4. So now if we solve this equation, distributive property on the left side, and then setting this quadratic equal to 0, we need to subtract 7x, so that's x squared minus 4x, and then add 7, so plus 3. If we factor this, we get x minus 3 times x minus 1, which gives us a solution of x equals 3 or x equals 1. If we look at these two solutions, in number 3 we're asked to plug our solutions back into the equation to check them. So for the solution x equals 3, if I plug that in, I get 7 over 3 squared is 9, plus 3 times 3 is 9, minus 4, equals 1 over 3 minus 1. On this side I have 7 over 14, and on this side I have 1 over 2. 7 over 14 is equal to 1 over 2, so we're good. Now on the second solution, x equals 1, if I plug that in, 7 over 1 squared is 1 plus 3 minus 4 equals 1 over 1 minus 1. What happens here is we have 1 divided by 0 and we have 7 divided by 0. We can't divide by 0 because dividing by 0 is undefined. So we can see here that only x equals 3 is one of the solutions. Now if we go back to the original equation and now solve it using the other strategy, which is creating common denominators, let's see what happens there. So if I rewrite the original problem, I'm going to rewrite the denominator of this fraction in factored form. And then the right side of the equation is missing the factor x plus 4. So I'm going to put x plus 4 multiplied by both the numerator and the denominator here. Now that I have the common denominator x plus 4x minus 1, if I were to multiply this whole equation by the common denominator, x plus 4x minus 1, these both would go away. So I end up with an equation without fractions. 7 equals, the numerator here is 1 times x plus 4. So we only get one solution of x equals 3 when we do the problem by creating common denominators. Whereas when we did cross multiplication, we got two solutions and then one of them ended up being extraneous.